Dear students, you have been studying Laplace transform, inverse Laplace transform since from last 3 sessions. In today's session, we will take convolution theorem and application of Laplace transform, where we can use this Laplace transform technique to solve linear differential equation with the initial conditions given. So let us now take convolution theorem first. First of all, we have to understood or know what is the meaning of convolution, or we can say it is a product, convolution product between two functions. So whenever a function of t, that is f of t and g of t, is given, the convolution between two functions is denoted by f star g, which is defined as integral. So f star g is integral of f of u g of t minus u, integrate this with respect to u between the limit 0 to t. So here I have to integrate f and g by replacing t by u and t by t minus u with respect to u between the limit 0 to t. So what is the convolution we got? The convolution is nothing but, convolution product is nothing but integral in this format. Now what is the Laplace transform of this convolution product? That is L of f star g, I can define by convolution theorem. The convolution theorem says the Laplace transform of convolution product is product between the Laplace transforms. So L of f star g is just the product of corresponding Laplace transforms of these two functions. So I can have L of f star g means L of the integral format is equal to L of f of t into L of g of t, or it is nothing but f of s into g of s. Now what is the use where we can use this convolution theorem? We can use this convolution theorem in finding L inverse of functions where the function is product between two functions, or I can say rather, if a function, let me take this product as f1 of s, a bigger function where I cannot get L inverse immediately, but if I split that into two simpler functions whose L inverse is obtained immediately, then L inverse of their product is nothing but just f star g. So convolution between two functions which we can integrate thereafterwards, where I get f of s L inverse as f of t and g of s L inverse as g of t. These two functions I got. Then L inverse of f of s into g of s is nothing but f star g, that is just the integral f of u g of t minus u du between the limit 0 to t. So that is what we have here. So L inverse of f of s into g of s is equal to f star g. So remember this result. We can take this result while solving the problems using convolution theorem, find inverse Laplace transform. So let us move on to the problems. So I have first problem, using convolution theorem find the inverse Laplace transform. So what is the function here? Student, just observe here, 1 by s square plus a square the whole square. In case if it is s square plus a square, just s square plus 1 by s square plus a square, I can find L inverse immediately. I know that it is sin 80, but here we have 1 by s square plus a square the whole square. So that's why we cannot get L inverse immediately. So there comes convolution theorem. So I can split this into two simpler function, 1 by s square plus a square and 1 by s square plus a square again. So each function, its L inverse is immediate. What is the L inverse of each? That is nothing but sin a by a. So I have f of t as well as g of t, both are 1 by a sin a. So thereby, by convolution theorem, L inverse of f of s into g of s is nothing but f star g. So what we have, f star g means it is integral f of u g of t minus u integral with respect to u between the limit 0 to t. Just substitute. So I have substituted where f of u is sin au, replace t by, you have to just replace t by u, and g of t minus u, you have to replace t by t minus u, that is sin of at minus au. 1 by a is anyhow constant in both the case, 1 by a square I have taken out. So integrate by using sin a sin b. So what is sin a sin b formula? Half into cos a minus b minus cos a plus b. For our convenience we can substitute here itself, a is au and b is at minus au. So thereby a plus b gives at, a minus b gives 2au minus at. So substitute, we have 1 by a square cos 2au minus at minus cos at. Integrate this with respect to u between the limit 0 to t. So what is the integral of cos? We know that it is sine. So I have the integral of cos 2au minus at. So that is sine 2au minus at. But remember, you have integrated this with respect to u. So that's why coefficient of u is 2a. So what about the second term, integral of cos at? So students, here you have to be very careful, because sometimes we will have a impression that integral of cos at is sin at, which is not correct, because here cos at is totally a constant since we are integrating with respect to the variable u. So that's why cos at is constant, means just integral of 1. So u cos at. Now apply the limit. Upper limit is t, lower limit is 0. Upper limit minus lower limit. So when I apply the limit t, upper limit, we have cos 2at minus at. Sorry, here I have to apply the limit for sin 2au minus at, that is sin at minus lower limit, when t equal to, u equal to 0, I have sin of minus at. Sin of minus is minus sign, outside already I have minus, that's why it is plus sin at by 2a. Correct? So the next step is sin at by 2a plus sin at by 2a. And what about the second term? So that is a t u cos at I had. So I have to apply the limit for u, that's why cos at is anyhow constant, just apply the limit for u. So t minus 0, that is t, so t cos at, so I got t cos at. So this is the answer, 1 by 2a square sin at by 2a plus sin at by 2a, but still we have a scope for simplification because these two are the like term. Collect it, so take it together, 2 times sin at by 2a, 2 cancel, sin at by a. If you want, you can take a common outside by multiply or taking LCM as a. So that means you will get sin at by a minus t cos at becomes sin at minus at cos at with the 2a cube outside. If you want, you can do that simplification. So I got the answer is 2a cube sin at minus at cos at. Correct? I hope you understood this. So only the thing is you have to integrate carefully by using relevant formulas. So let us move on to the next problem. So I have here s by s square plus a square the whole square. Again, directly you cannot simplify by splitting this into two simpler functions. So which I have taken as s by s square plus a square, 1 by s square plus a square, both gives a L inverse of first is cos at, the second one is sin at by a. So I got f and g, f of t, g of t. So what is the convolution theorem? L inverse of product f of s, g of s is f star g. So how f star g is integral, just substitute in that convolution, that is f of u into g of t minus u, integrate with respect to u between the limit 0 to t, just substitute. So what is f here? Cos at, that's why it is cos au, and g of t is 1 by a sin at, replace t by t minus u, which gives 1 by a sin at minus au. So I have this to integrate further. So what is the formula now? How we can integrate? You know that it is cos a sin b or sin a cos b, however you take. So better you take cos a sin b. So the result is half sin a plus b minus sin of a minus b. Substitute and simplify, first get a plus b and a minus b, which is at, and a minus b is 2au minus at. So this gives 1 by 2a integral of sine at minus sine of 2au minus at. Integrate. So again integral is with respect to u, that you have to be very careful. So integral of first term is just constant, sine at is constant. So integral of that is u sine at. The second one is a cos 2au minus at. Sorry, integral of sine, so is minus cos, so minus cos of 2au minus at divided by 2a, but outside I have minus, so minus of minus plus cos 2au minus at by 2a. So we get 1 over 2a u sin at plus cos 2au minus at by 2a. Apply the limit carefully. For u you have to take the limit. So first term is t minus 0 sin at, that is t sin at. Second term as usual, so apply upper limit. 2at minus at means at, cos at by 2a, minus when u is 0 cos of minus at, but cos of minus theta is cos theta, that's why it is cos at only. So I have cos at by 2a minus cos at by 2a, that means these two term gets cancelled. So I can write the final answer as 1 over 2a into t sin at. Correct. Shall we move on to the next? We'll take one more to understand better. So what is L inverse of s by s minus 1 s square plus 1? So s by s minus 1 into s square plus 1. So here again we have to use convolution theorem. So split into two simpler function. So I have taken s by s square plus 1 into 1 over s minus 1. So here you have to be little cautious. It's simple actually. So I have taken s by s square plus 1, 1 by s minus 1. So neither, instead by taking 1 by s square plus 1, s by s minus 1. So why? Because s by s minus 1 L inverse directly I cannot get. I can get by simplification, by further simplification. But s by s square plus 1 as well as 1 by s minus 1 both gives L inverse. One is cos and the second one is exponential. So immediately I can get. So what we have, L inverse of s by s square plus 1 is cos t, L inverse of 1 by s minus 1 is e power t. So by convolution it is f star g, as you know already we have taken. So just apply that definition, convolution, integral f of u g of t minus u du, and substitute immediately. So that is cos t, correct. So we can write cos u into e power t minus u, because g of t is e power t. So what is e power t minus u? I can split that by using a power m plus n, a power m into a power n. So e power t into e power minus u, but e power t here is constant, so I can take it out. So because integral is with respect to u, so integral is with respect to u. Just integrate this. How to integrate? So we have a formula for that, correct? E power at cos bt, integral formula we have, so take that. So e power at in cos bt integral is what? E power at by a square plus b square into a cos bt plus b sin bt. So here a is minus 1 and b is 1. Substitute that. So you'll get e power minus u by minus 1 square plus 1 square, that is 2. A cos bt, that is minus cos u, plus b sin bt, that is 1 sin u. Apply the limit. Upper limit is 2, t, lower limit is 0. Upper minus lower limit. So what we get? So I get e power t by 2, we can take it out, constant. So e power minus t into minus cos t plus sin t while applying upper limit. Minus of lower limit is e power minus 0 minus cos 0 plus sin 0, but sin 0 is 0. So minus cos 0 is 1 and e power 0 is 1. So minus 1, minus of minus plus 1. So this is the answer. Or if you want, you can take e power t inside. E power t by 2 into e power minus t, that is e power 0. Anyhow it is 1. So 1 by 2 minus cos t sin t, or sin t minus cos t by 2, and e power t by 2 into 1, that is e power t by 2. So I can write the final answer 1 by 2 times sin t minus cos t plus e power t. Yes. So take some more problems which is given at the end. So take or solve those problems. Try to understand the concept of convolution theorem. So let us move on to the last part here, that is application of Laplace transform, where we can use this Laplace transform as a tool to solve linear differential equation with the initial condition given. So for that we need one result. So what is that result? Here comes Laplace transforms of derivative. So that means if I know the Laplace transform of f of t, I can get Laplace transform of f dash of t. So the Laplace transform of f dash of t is given as s of L of f of t minus f of 0. So that means if I know the Laplace transform of f of t, then Laplace transform of f dash of t is obtained just by multiplying Laplace transform of f of t by s minus f of 0. So what is Laplace transform of f double dash of t? If I extend this, Laplace transform of f double dash of t will be s square L of f of t minus s into f of 0 minus f dash of 0. So how we got that? Just observe carefully. F dash of t, the order of the derivative is 1. So we have to start with s power 1, and in the ascending order the next term should have s power 0. Correct. That's why f double dash of t here order is 2. That's why I told it is s square L of f of t minus s f of 0 minus there will be one more term, that is s power 0 1. So with the f dash of 0. So it is in the increasing order f dash f double dash at t equal to 0. So I have to find f double dash of t Laplace transform. In the result says s square L f of t minus s f of 0 minus f dash of 0. So rest all with the minus sign except the first term, and Laplace transform of f of t, that is f of s, is always with the highest degree term. So if it is f double dash, we will have s square. If it is f triple dash, we will have s cube L f of t. There afterwards s square f of 0, s f dash of 0 and f double dash of 0 with all minus sign. So this result I can use while solving linear differential equation, because we know that linear differential equation, that means if I want to solve a second order differential equation, d2y by dx2 plus 3 dy by dx plus 2y equal to e power x. So we have derivative of y with respect to x of second order, first order, etc. So if I know the Laplace transform of y as y of s, if I know that Laplace transform of y as y of s, I have denoted like f of t Laplace transform f of s. Now I denote it as Laplace transform of y, y means y of t is y of s. For our convenience we have taken it as capital Y. So here capital Y means y of s. Then what is Laplace transform of y dash dy by dt, that is the derivative. So what is the Laplace transform of y dash of t? By the result which we have, I can write it is s into Laplace transform of y of t, that is y of s, s y of s minus y of 0. So I have L of y dash, that is Laplace transform of y dash is nothing but s into y minus y of 0. Just taken the result as it is. Now take L of y double dash similar way. So what is L of y double dash? S square into capital Y means Laplace transform of y of t minus s into y of 0 minus y dash of 0. So just observe that result carefully. Y double dash means second order. So I have to start with s square, then in the descending order it is s, then s power 0, that is coefficient is here 1. And highest degree term s square is always along with capital Y, that is Laplace transform of y of t, that is y of s I denote capital Y, minus the next number is s, along with this we have y of 0, the functional value is at t equal to 0. One more term I have with the constant 1, so we have to take y dash of 0. So can you guess now what will be the result for y triple dash? Laplace transform of y triple dash is s cube capital Y, that is Laplace transform of y of t, minus s square y of 0 minus s y dash of 0 minus y double dash of 0. Correct? By applying this results, I can find the solution for a given differential equation. So how we can solve the differential equation? Wherever initial condition is given, that is y of 0, y dash of 0 for a second order differential equation, or if it is a third order differential equation, they will provide three conditions: y at 0, y dash at 0, y double dash at 0. So whenever a differential equation is given, the procedure is very simple. So we have to first write the differential equation in a symbolic form by taking notation dy by dx as y dash, d2y by dx2 is y double dash, or with respect to t variable t, dy by dt as y dash. So then apply Laplace on both sides, apply the results. The result is nothing but Laplace transform of y is capital Y, y dash we have here Laplace transform y double dash, as well as if it is third order we have Laplace transform y triple dash, and substitute all the conditions given: y dash 0, or y at 0, y dash 0, y double dash 0. Substitute and make as a function of y on one side, so that is a function of capital Y, expression of capital Y on one side. So we get y of s. So once we get y of s, that is a function of s, so I can get back y of t, that is L inverse of y of s. So we take one or two problems, you can get the concept easily. So I have here solve the following equation by Laplace transform method. The simplest problem here, we have only homogeneous differential equation. So if I get the earlier method means general solution, we need to find yc complementary function. Only complementary function I should get. So by Laplace transform method, I have to solve this differential equation. So how to solve this? So let me take the results. What is the results required here? Here comes the result. I denote Laplace transform of y of t is capital Y, that means y of s. Then Laplace transform y dash and y double dash, these two results are required because we have y as well as y double dash. So y Laplace transform of y dash is what? S into capital Y minus y of 0. But if you want, substitute given condition here itself, make it simple. So y of 0 is 0 means your Laplace transform of y is s into capital Y. So the Laplace transform y double dash is s square into y minus s into y of 0 minus y dash of 0. Y of 0 is 0, y dash of 0 is 2, so I get s square y minus 2. So thereby if I substitute here after applying Laplace, actually it is Laplace transform y double dash plus k square times Laplace transform of y. So that gives what it gives. Taking Laplace transform on both sides and simplifying, what it gives. So I have s square y minus 2 plus k square into, what is that, k square into y, k square into y. So we can get s square y minus 2 plus k square into y, because Laplace transform of y is y itself, correct. Laplace transform y double dash is s square y minus 2. This is not required here actually. S of Laplace transform y dash is not required. Y double dash we got, as well as Laplace transform of y. Just substitute here. Y double dash Laplace transform is here. K square times Laplace transform y is capital Y. So function of y, s square plus k square y, I mean expression involving y. Y means y of s on side, and rest all free from capital Y. that is 2 we have taken to right side. So what is y of s therefore? Y of s I can get y of s is equal to 2 by s square plus k square. So from this y of s I need to get y of t, function of t, that is the solution for this linear differential equation. How to get from this? How we get y of t? For that we have to apply inverse Laplace transform. So L inverse of y of s is y of t. So y of t is L inverse of y of s. So what is the L inverse of 2 by s square plus k square? It is of the form 1 by s square plus a square sine. So it is sine at by a. So therefore here it is sine kt by k. So we get finally the solution for the given equation is 2 by k sine kt. So students, we take one more problem. I hope you can give me the answer step by step how we can solve this now. First, write all the results and meantime you substitute the condition also. Make it simple. So I have to apply Laplace on both sides and then apply the result of Laplace transform y. If it is capital Y, what is y dash, what is y double dash, substitute the condition. And also on right side I have e power minus t. I know the Laplace transform e power at is 1 over s minus a, and all that I can simplify. So I use all the result on one side. So I got L of y is y capital Y, L of y dash is s into capital Y minus y of 0, but y of 0 is 0, that's why it is just s into y capital Y. And what about y double dash? S square y minus s into y of 0 minus y dash of 0, but since both y and y dash at 0 is 0, so I get only s square y. So substitute the given equation y double dash plus 4y dash plus 4y equal to e power minus t. Taking Laplace transform on both sides gives s square. I have just substituted directly, that's why s square y plus 4sy plus 4y is equal to Laplace transform e power minus t, that is 1 over s minus of minus 1. A is here minus 1, so s plus 1. So left side already it is a function of or expression of capital Y. So what are the coefficients? S square plus 4s plus 4. So coefficient of capital Y is s square plus 4s plus 4. So I have s square plus 4s plus 4y equal to 1 by s plus 1. Thereby expression y I can get as 1 by s plus 1 into s square plus 4s plus 4 is nothing but s plus 2 the whole square. So by partial fraction I can split that as a by s plus 2 the whole square plus b by s plus 2 plus c by s plus 1. I need to find the numbers a, b, c, the values for a, b, c. So that by partial fraction I hope you can get. So here comes a, that is minus 1, c is 1, and to find a and b, sorry, a and c I can immediately find by direct method. How we can get? So a denominator we have s plus 2 the whole square, so left out factor close s plus 2 the whole square, so 1 over s plus 1 at when it becomes 0 minus 2, so at s equal to minus 2, that's why it is minus. Similarly c I can find because we have denominator s plus 1. So what is that? Denominator s plus 1. So the left out factor is s plus 2 the whole square in the 1 over s plus 2 the whole square when at s equal to minus 1. So at s equal to minus 1, that gives 1. Now how to find b? So to find b, either you can compare the coefficients on both sides, correct? So if I take the LCM here, s plus 2 the whole square into s plus 1, we will have a into s plus 1, b into s plus 2 into s plus 1, c into s plus 2 the whole square. If I want b, then coefficient of highest degree term with b is s plus 2 into s plus 1 means s square. So you have to compare the coefficient of s square on both sides. You know that. So coefficient of s square is one is b, another is c into s plus 2 the whole square. That's why it is coefficient is c. So b plus c, left side we have coefficient of s square is 1. So b plus c is equal to 1. So what we have, b is equal to thereby minus 1. b is minus 1. Substitute. So we got L inverse of y means L inverse of minus 1 by s plus 2 the whole square plus L inverse of 1 over s plus 2 plus L inverse of minus -1 by s plus 2 and L inverse of 1 by s plus 1. Second and third one is simple, e power exponential. So I can write exponential minus 2t and exponential minus t. How to get the first one? So here instead of s plus 2 the whole square, if I had just s square, it is s power n formula, 1 over s power n. So obstacle is 2. I remove that by taking e power minus 2t out. So remains L inverse of 1 by s square. So that gives t power 2 minus 1 by 2 minus 1 factorial, that is t. So I have the answer minus t 2 e power minus 2t minus e power minus 2t plus e power minus t. So the answer is immediate, or we got the answer y of t, that is the solution of problem. So I have one more now. Y double dash plus 4y dash plus 3y equal to e power minus t with y of 0, y dash of 0 given as 1. Initial step I hope you can write. It is simple. Apply all those results and substitute meanwhile the condition. Meantime you have to substitute the condition. Y of 0, y dash of 0 is 1. So what I got is Laplace transform of y is capital Y dash is s into capital Y minus 1 and y double dash is s square y minus s minus 1 and e power minus t, for that matter Laplace transform is 1 over s plus 1. So given the equation, write in symbolic form, y double dash plus 4y dash plus 3y equal to e power minus t. Take Laplace transform on both sides and substitute the results what we obtained there. So I got s square capital Y minus s minus 1 plus 4 times sy minus 1 plus 3y equal to 1 over s plus 1. What is the coefficient of y? So you take coefficient of y, expression y on one side and free from y on other side. So I have s square plus 4s plus 3, correct? No, s square plus 4s plus 3y is equal to 1 over s plus 1 plus s, because minus s goes that side, plus s minus 1 minus 4, that is minus 5 comes this side, plus 5, correct? So take LCM, s plus 1 LCM and simplify that. So we'll have s plus 5 into s plus 1 plus 1 divided by s plus 1. Simplify that, you will get s square plus 6s plus 6 divided by s plus 1 and take the left hand side coefficient s square plus 4s plus 3 this side. So that is s plus 3 into s plus 1, factorize it. So we'll have s plus 3 into s plus 1. So that's why we have earlier s plus 1 and this s plus 1, s plus 1 the whole square into s plus 3. So just go through it, you can simplify, it's not a big task. Now split, resolve into partial fraction, a by s plus 1 the whole square, b by s plus 1, c by s plus 3, where a, b, c values I got there. On left side we have there a, b, c values. You know the technique now, adopt that. Now substitute back the values of a, b, c and then apply L inverse. So L inverse of y gives y of t. So half times t e power minus t plus 7 by 4, because b value is 7 by 4. 7 by 4 L inverse of 1 over s plus 1 is e power minus t. C value is minus 3 by 4. L inverse of e power s 1 over s plus 3 is e power minus 3t. Whereas the first term a by s plus 1 the whole square becomes half into L inverse of 1 over s plus 1 the whole square, again the same, by shifting. So you can take e power minus t out, left out will be L inverse of 1 by s square, which gives t. So the answer y of t is half into t e power minus t plus 7 by 4 e power minus t minus 3 by 4 e power minus 3t. So that covers the first module, Laplace transform. I hope you understood all concept what we have taken in last 3 plus today's one session. Just go through it once again. So some more problems we'll do in the coming classes. Before that, practice yourself, try to solve problems which we have already given in the exercise section. If you have any doubts, you can come up with the doubts, ask all those doubts, clarify your doubts. So for the next class you can solve some more problems on all these concepts. So what we have taken in today's class, I can take a summary. So we have taken two concepts. One is convolution theorem, so remember that result. The second one is results which we require while solving linear differential equation, so which we obtain from the Laplace transform of derivative. So the Laplace transform of derivative, we know that how we can get the Laplace transform of derivative. So you can directly use these results while solving linear differential equation. So take these problems, we have altogether 6 problems. Try to solve these problems and practice. Thank you for listening.